Alright, you guys, I'm going to show you how to work this problem. Let me just add a new page. Okay. Alright, so to start off with, the way we're going to solve this is by knowing, okay, number one, we have our gene frequencies, which are little q and little p. And then we also have our genotypic frequencies, which are big Q, big P, and H. And then, for those of you who weren't in class recently, a good way to remember this is genotypic frequencies are little q, big Q, or, sorry, big P, big P, and then big P, or big H, little h. So those are your genotypes, basically. You can use any of those letters. Alright, and then furthermore, we know that big P is equal to little p squared. H is equal to 2 times P times Q. And then Q is equal to little q squared. Okay? So, in this problem it says, gray color in horses is caused by a dominant gene G, and other colors by its recessive allele little g. A survey of 10,000 rabbit foals showed 84% gray. Assume randomizing for color among the parents. Alright, so we know that G is dominant, so anything that has big G, little g is going to be gray, and then anything with little g is going to be something else. So the easiest way to solve this is to start by solving for what's recessive, because for the dominant ones, we don't know which is going to be which, if it's going to be big G, or big G, little g. So the way we do this is 100 minus 84 is equal to 16, right? And that's going to be our percentage that's recessive, which means that 16% is equal to Q. Okay, so now that we have Q equals 16, we can solve for little q. So Q squared is equal to Q, so that means the square root of 16 is equal to 0.4, which is equal to little q. And now that we have little q, we can go ahead and solve for little p. So 100 minus 0.4 is equal to 0.6, which is equal to little p. Now that we have that, we can solve for our other two genotypic frequencies as well. So H, which is our big G, little g, is going to be 2 times 0.4 times 0.6, which comes out to 0.48. Okay, and then our big P is equal to little p squared, which is equal to, or let me do it like this. So that's equal to 0.6 squared, which is equal to 0.36. Alright, so it says, what are the estimated gene frequencies? So that's little q, little p. So little q is equal to 0.6. Little p is equal to, what did I say? Oh, sorry, 0.4, yeah, little p is equal to, or sorry, q is equal to 0.4, and p is equal to 0.6. Okay, and what percent of the gray foals are expected to be heterozygous? So that's a big G, little g, and we know that that is equal to H, which means it's 0.48, so it's going to be 48%. And what percent of the parent group are expected to be heterozygous? And that's the Varnemeyer, whatever it's called, equilibrium. So that's going to be the exact same, since it's a big group of over 10,000 horses. So that's also going to be 48%. And then what is the probability that a randomly chosen stallion will be homozygous GG? So homozygous GG is going to be big P, which is 0.36, so 36%. And then you just do this exact same thing to solve the second problem.